5G supports multiple service verticals which are very different in terms of the expectations from the network resources. To support these different service verticals, we need to logically divide our network which are actually implemented over a single physical network. How do we really do it? The answer is 5G slicing. So in this particular session, we are going to talk about 5G slicing. My name is Sanjay Kumar and I am from NanoCell Networks. Now if we look at this, we have talked about this picture earlier. Now in this particular scenario, we are going to talk about these particular three different service verticals, which are EMBB, URLCC and MMTC, which are very different. Now in case of EMBB, in case of URLCC and MMTC, what kind of services we are expecting, we are going to talk about these things in the next slide. Now in this case, when we talk about enhanced mobile broadband, we are talking about our expectations are nothing but 20 Gbps data rate in downlink and 10 Gbps in uplink. So our data rate requirements are very high and we are expecting these data rates to be delivered up to at least 100. These are the peak data rates what we are expecting, but at least for every user experience data rate we are expecting up to 100 Mbps. However, in case of MMTC, the data rates are not that important. What we are looking at 10 raised to the power 6, which is nothing but 1 million subscriber per square kilometer. So in a given square kilometer, we are expecting up to 10 raised to the power 6 subscribers, which are nothing but 1 million subscribers. However, in case of URLCC, our data rates are not that important. What is more important here is ultra reliability, highly reliable network, and very low latencies, sub 1 millisecond kind of latencies, where we are expecting latencies of 1 millisecond or less. To achieve all these things, these are the completely different network requirement what we have. The network requirement for EMBB, the network requirement for URLCC and network requirement for MMTC are entirely different, but the challenge is that we have to run all these different service verticals on a single network infrastructure. How do we really achieve it? To achieve this, what we need to understand is we have to, just to give an example, high data rate, more number of devices, low latency and high reliability communication. To do this, we have to divide our network logically, but based on a single physical infrastructure. And the answer for this is slicing. So in case of slicing, what we do is we have something called as management and network orchestration, and based on some kind of automation, based on some kind of machine learning and some kind of artificial intelligence, the whole network is divided into something called as slices. So slices are basically the logical part of the single physical network. So what we see here is the services are decoupled from the underlying infrastructure. However, to do this, we need to have a complete, very efficient management network orchestration. So in this side, what we see here is we have the applications for URLCC, EMBB, MMTC, and we have public safety slices. Now, if you look at this, we have a separate dedicated network for each different kind of services, and every different kind of services is carried as a slice. All the slices are completely isolated from each other and they run from the radio network. The slices run from radio network to the transport network as well as to the core network. So when we say slices, they should support end-to-end kind of implementation where they can have these infrastructure, these resources dedicated for one particular slice end-to-end. End-to-end means where we are starting with the client or the user and going up to the cloud network or a 5G core network. So we need to have a slice support in RAN network, the transmission network as well as the core network. So in RAN network, we do it by having different kind of layer architecture, different kind of device, different kind of separated split layers. In case of transport networks, we need to have new types of transport networks, which are typically called as 5G enabled transport networks, which supports slicing kind of parameters. They go with some different kind of mechanism of slicing called as soft slicing, hard slicing, channel level slicing, physical level slicing. We are not going to talk about those many details here, but transport network should also support 5G, the slicing. And the core network typically achieve it by running a different virtualization techniques and by having multiple VMs, where we can have some of the network functions dedicated for one slice and some other network functions are dedicated to another slice. So every slice can have a separate dedicated functions, or they can also have one network function taking care of multiple slices as well. So I can have one particular network function used by all the slices, and for some of the network function are separated by one particular for between the slices. When we look at this, so we have in this case of slice 1, we are using the PHY layer, MAC layer, RLC layer, PDCP layer. So we have end-to-end layer architecture in radio network, and we have the network architecture of core network, which is typically used by Polis slice, used for Polis services, which is for enhanced mobile broadband. However, if you look at the next example here, we have one particular device using slice 2 and another device which is using slice 3. They both are going through the same radio slice, which is combined at the physical and MAC layer, but they have separated layer of RLC, PDCP and SDAP, but they are using exactly the same core network function. Right, so typically they are using this different core network function. So one is for normal EMBB and another one is for cars EMBB. The car infotainment services in the cars can be provided by cars EMBB services. However, this device here is actually consuming two slices, slice 3 and slice 4. Slice 3 is for the infotainment, which is typically using the car EMBB slice, and slice 4 is using the connected car kind of services, which is nothing but the car IoT services. So what we see here, what we understand here is one particular device can achieve multiple slices, can connect to multiple slices, and I can have one radio slice consumed by two different kind of slice, and we can also have some core network function which can be consumed by multiple slices as well. Now if we look at this video, this gives us a lot of flexibility in allocating the radio resources. So if we see here, we have three different network defined. So we have one logical network here, we have another logical network here. So this logical network is here the policy EMBB, this is car IoT, and this is the normal EMBB or cars EMBB kind of slice. So what we did here is we divided the same physical infrastructure into multiple logical network, and that is where our slicing plays a major role. So every node or resource is dedicated or shared in such a way to meet the service requirement of the slice. So typically the operators are going to have a certain SLAs for these particular slices, and they are going to meet those SLAs. Those slices can be sold to a MVNO, for example, can be given to a particular mobile virtual network operator, or can be sold to a customer like police or maybe some industrial automations and stuff like that. So slicing gives us a lot of flexibility how it is allocated to the end user, and this is typically different than QoS. QoS was happening on the same network. Now in every slice also you can have QoS implementation, and you can actually prioritize your traffic based on the requirement in that particular slice. So slicing is way more effective than quality of service. Quality of service was actually mostly the best effort kind of services. However, the slicing gives you a completely different control over your network, where you can use your network very efficiently, and that is where the slicing is something which is very new to the 5G network, very new to the cellular network as well, and going to play a major paradigm shift in the telecom networks, in 5G networks. That's all for this video. If you like this video, please like and subscribe our channel, For any more information, please feel free to visit www.nanocellnetworks.com or email us at info@nanocellnetworks.com. Please like and subscribe this channel.